Dear friends, hoping that you are fine and the paper under our consideration right now is the October-November 2024 paper 4 variant 2, and I will be discussing right now with you people the electricity and magnetism questions. So that is question number 7 as well as question number 9. So a washing machine has an electric motor and an electrical heater. Figure 7.1 shows a simplified circuit diagram for the washing machine. The heater has a resistance of 25 ohms and the power supply. So the resistance that is 25 ohm for the heater, and the power supply has an electromotive force of 230 volts. Even in this diagram we can see it means here electromotive force that is 230 volt. The resistance of this heater, it is 25 ohms. For motor we don't have any idea. This is the symbol for motor, and here this is the ammeter. State what is the meaning of electromotive force. We can say that it is the amount of electrical energy, it is the amount of electrical energy given to or supplied to unit charge to move it around a complete circuit, around a complete circuit. Even you can write the equation also, because 2 marks are there. So you can say this is equal to energy per unit charge, V is equal to E over Q. State the potential difference across the heater. As heater and motor, they are connected in parallel to each other, and in a parallel combination of resistors or components, potential difference stays the same across each component because they are directly connected to the power supply. So this will be 230 volts. Calculate the current in the heater. Very simple. Resistance is there, voltage is there, so current we can easily calculate by Ohm's law. V is equal to IR. Make I as the subject of equation, that will be equal to V over R, and it means 230 divided by 25. So as we simplify, we are getting the answer 230 divided by 25. Answer is 9.2. So it means current in the heater is 9.2 amperes. Don't forget to write the unit with the final answer. The current in the motor is 1.6 amperes. That is the current in the motor. So determine the reading on the ammeter in figure 7.1 and explain your answer. So now my dear friends, first current in ammeter, this will give us the total current, I total. Now there are two current. I current in passing through this ammeter will be equal to the sum of the currents flowing through the heater and the motor, and both the currents we are having. So when the resistors are connected in parallel, we know the total current is equal to the sum of the branches current. So current in heater plus current in motor. So that's what I'm going to do here. I'm going to write here ammeter reading mean total current we need. I total will be equal to current through heater plus current through motor. Current through heater, that we have calculated already, 9.2, and the current through motor, it is mentioned 1.6 amperes. So as we will simplify, 6 plus 2, it will be 8. 9 plus 1 it is 10, so 10.8 amperes. So explanation, we can say total current in a parallel circuit, let me say this way, in a parallel circuit is the sum of the currents in the branches. So motor and heater actually connected into the branches. So this is question number 7, basically on Ohm's law and combination of resistors, like in this case the parallel combination of resistors. That is the basic for this question. If you have that concept very strong, so there is no problem at all in this question. It is a straightforward question. Then we will talk about another question on electricity, which is question number 9. Figure shows a wireless charging plate used to charge the battery in a mobile phone, cell phone. The coil of the wire is the part of electrical circuit, and what is mentioned, the charging plate is connected to an AC power supply. Now AC power supply will be providing the alternating voltage or alternating current which keep on reversing its direction with time. The power supply is turned on. Describe the magnetic field around the charging plate in terms of magnitude and direction. Now very simple question and the basic of the properties of the current causing magnetic field. So as the current is passing through, the coil is alternating. So when current is creating a magnetic field as it is passing through a conductor, so the magnitude of current depends upon the magnitude of current. The magnitude of magnetic field produced depends upon the magnitude of current. Direction also depends upon the direction of current. So if the magnitude of current will be changing, so the magnitude of the magnetic field will also be changing. And if the direction of current is reversing with time, it means the direction of the magnetic field will also be reversing. So 2 marks are there and 2 valid points we can write in terms of magnitude and direction. The magnitude of magnetic field is changing, and the direction of magnetic field is also changing because of the AC power supply. Now this is something which we are nowadays finding this facility in some all over the world famous food chains. So we are placing our even in some shopping malls also this facility is available nowadays, that you can put your mobile on some particular place and it is starting to charge. The battery is starting to charge. Battery of the mobile is starting to charge. A mobile phone is placed on a charging plate as shown in figure 9.2. The coil in the mobile phone is a part of the separate circuit that charges the battery. So there is a secondary coil, there is a charging plate, and there is a primary coil. So it is just like the concept of transformer without the presence of iron core. The coil in the charging plate and the coil in the mobile phone acts like a transformer. That is also mentioned by the examiner. Explain why there is a current in the secondary coil shown in figure 9.2. Again 2 marks are there, and very basic concept we will be using. We will say there will be a there will be a changing magnetic field in the secondary coil. Why? Due to primary coil. Due to primary coil. So an EMF is induced in the secondary coil. Our voltage is induced. So voltage is induced in the secondary coil, and if there is voltage in the secondary coil, of course there will be current in the secondary coil. Current is directly proportional to EMF or the voltage. So what is the concept? Even you can say, we know one thing, that the primary coil is connected to AC power supply. It means the magnetic field in primary is changing. Now secondary coil is in the influence of the primary coil. Our secondary coil is within the range of the primary coil. So if the in primary coil magnetic field is changing, so it means in secondary coil also magnetic field will be changing, and a changing magnetic field leads to an induced EMF according to Faraday's law of electromagnetic induction. So it means voltage will be induced in the secondary coil, which is leading to the current in the secondary coil. That is what we have to answer. Then, my dear friends, suggest why the transformer made from the charging plate and mobile phone is not 100% efficient. You can say some of the energy is wasted or is transferred. Some of the thermal energy, better to say, thermal energy is transferred to the surroundings. So some of the energy is transferred to surroundings as thermal energy. So like this you can say, that's why it's not 100% efficient. Okay, my dear friends, now the mobile phone battery can be recharged using this charging plate and stores this much amount of energy. When fully charged. The current in the secondary coil is 0.36 amperes when the output voltage is 12 volt. So current is given, V is given, so calculate the time taken to fully recharge the completely uncharged battery. So question looks like twisted. Statement is not that much easy one, but the data is leading towards the very common equation of energy, electrical energy or energy stored. E is equal to VIT. Make T as the subject of equation. Energy will be equal to, time will be equal to energy over voltage times current. So we have all the data now. Energy is 4.5 times 10 raised to power 4 over voltage is 12 and current is very much small, 0.63. So let's check what is the answer. So 4, 5, then 0, 0, 0, which leading towards 4.5 times 10 raised to power 4 divided by 12, and we are getting this, and then again divided by 0.63, we are getting 5952 seconds. So 5952 0.52 seconds. So we can write it, if you ask me, more suitable to write 6000 seconds to the nearest thousand, or even you can write 5950, or even you can write 5.95 times 10 raised to power 1234 seconds. So anyway, answer is correct. So my dear friends, in this case, now answer will be equal to roughly 6000 if we are going with the nearest thousands. Then calculate the charge passing through the battery in 60 seconds. Be very careful. Mostly students are using the time in the previous part. I know in 60 seconds. Charge passing through the battery in 60 seconds. Charge Q. Time is there. Current is already there into the data. So we know basic equation of current. Current is the rate of flow of charge, Q over T. And if we cross multiply, we can get the charge Q is equal to I times T. We have current which is 0.63. Here it is given. Times we will go with 60. Because time is 60 seconds here. So my dear friends, 60 times 0.63, we are getting 37.8. So it means we can write simply 38, and unit of charge is coulombs. So 38 coulombs. Again, some basics from electrical quantities chapter topic, and also electromagnetic induction, meaning how the electricity is generated with changing magnetic fields, and the transformer basics are there to solve this question. And overall, not that much difficult question, this one also. So now, if you have any question, please feel free, you can ask me without any hesitation. And if you think that these explanations are useful for you, so please do share my channel link to your family and friends, and also subscribe my channel. And in the next video now, we will be talking about the last two questions of this paper based on nuclear and atomic physics and space physics. Stay blessed, my dear friends. Bye.